Okay, we can go ahead and get started here. So first, thank you everyone for joining us this evening on our panel on environmental resilience in Virginia. And before we get started here, we're going to go ahead and talk about a little bit about upcoming events that the Alumni Association has. So on Thursday, June 3rd, there will be a data and privacy now in the future discussion from 3 to 4 p.m. Then Thursday, June 17th, we have the virtual family bingo event that's going to be going on later in the evening from 7 to 8:30 p.m. And then near the end of June, we're going to have a discussion with the DC Coalition for the Homeless on Thursday, June 24th from 6:30 to 7:30. And then in terms of our event today, so tonight we have our moderator. We have Dr. Rob Rose, who's the Executive Director for the Institute for Integrative Conservation at William & Mary. And then we have our panelists, Elizabeth Andrews, who is the class of '84. She is the Professor of the Practice and Director of the Virginia Coastal Policy Center at the William & Mary Law School. Then we also have Dr. Molly Mitchell, who has graduated from William & Mary now 3 times with 3 different degrees. And she is a research assistant professor at the Virginia Institute of Marine Science at William & Mary. And you can submit questions, any questions you have for the panelists tonight, using the Q&A function at the bottom of our screen here. And this event will be recorded, so if you would like to go back and watch this event at any time, you will be able to. And with that, Molly, we can go ahead and start it off with you.
Thank you. And I will share my screen here. All right, so Elizabeth and I work a lot on issues that cross over in environmental resilience. So I work on the issues of what changes we're seeing and how those changes are impacting us. And so tonight I'm going to talk about climate change impacts in Virginia, mostly about flooding, which is what we're predominantly worried about. So sea level rise and precipitation. This is downtown Norfolk. This is what they call sunny day flooding. The water's edge is actually this blue building back here. So you can see there's quite a bit of a roadway that's underwater in this picture. And this is becoming a more common problem. So we're going to talk about why that is happening and how development and infrastructure can complicate the impacts. Okay, so we hear a lot about carbon dioxide, which is a big driver of change when we talk about climate change. But when we're talking about flooding, actually, the story is much more complicated. So this is a graph showing the increase in carbon dioxide abundance since the 1970s. And so that's one of the greenhouse gases. And the straightforward part of this is that as carbon dioxide increases, the air temperature also increases. Okay, so that is actually a pretty straightforward and easy to predict relationship. However, as air temperature increases, 2 other things happen. So first of all, we get changes in the atmospheric circulation patterns, and this leads to changes in the way the precipitation falls. So it changes the intensity of precipitation events, it changes the distribution of precipitation across the landscape. The other thing that changes, as air temperature changes, it changes water temperature. And that, combined with the changes in atmospheric circulation and alterations in pressure systems and that kind of thing, affect the local rate at which sea level is rising. So I'm going to talk to you first about air temperature just a little bit, and then about precipitation, and I'm going to spend most of the time talking about sea level rise, which is what we focus on the most at VEMS. Okay, so temperature, like I said, pretty straightforward. Carbon dioxide is increasing, temperature is also increasing. If we look, this is information for Fairfax County. These come from a community climate outlook that are done for each locality. You can find them online if you're interested in looking at them. So basically, compared to 1950, Fairfax is seeing 11 more days that have temperatures over 95 degrees. And we expect that by 2070 to get between 28 and 79 degrees. So this is a big change. And this, of course, has a lot of impacts for human health, particularly in urban areas. We do worry about this a lot. It also has impact for the environment. At BIMS, we work a lot with the fisheries, and the rising water temperatures that come with that increase in air temperature affect the amount of oxygen that's held in the water, which affects a lot of the species. Also, it can affect their species distribution. Precipitation hasn't increased that much overall. There's been a small increase in the annual amount of precipitation, but what we've really seen the biggest difference in is the number of high frequency events. So when we talk about, a 10-year storm, a storm that came every 10 years, we might see that every 5 years now. Okay, so we know that we're seeing more high intensity events. We're expecting to see that increase into the future. So up to 35% more days of heavy rainfall under the high emission scenario by 2070. And this is causing a lot of issues for our stormwater drainage, our roadway drainage, that kind of thing. This is one of the areas where you see a lot of interaction with development. So this is, just to remind us all, the Alexandria area. And every one of these little gray rectangles here is an individual parcel. And you can see in downtown Alexandria, you can't even distinguish between them. It's so close. So why is that a problem? Oh, and we have all our roadways too, which have to drain, right? So when we have a rural area, we get about 10% of any rain event comes off as runoff, okay? And the rest infiltrates or is lost through evapotranspiration. As we increase the development, that amount of runoff changes. So in urban areas, about 55% of that runoff is coming off at any given time. So if you think, okay, so a rain event that only came once every 10 years, maybe is coming once every 5 years now. And we have, instead of 20% of that storm running off and having to be dealt with within the first hour after the rain event, now we have 55% of that coming off and running off. And so this is where a lot of the flooding that's not tidal flooding is coming from. It's coming from this combination of increased rainfall intensity and increased development. One of the other things that is kind of interesting, we get particularly in the Hampton Roads area, we get a cross between the precipitation and the sea level rise or storm surge events. So this top picture here, okay, shows the way it's supposed to work. So we have a storm drain, right? The precipitation comes down around the house. The storm drain takes that storm and takes it out. So imagine this is designed for your 5-year storm. Okay, well, when you have storm surge come in, and with sea level rise, this is happening more and more often. That water actually takes up part of that pipe. So this pipe might have been designed for a 5-year storm, but now it can only hold the capacity of a 3-year storm. So what happens is we start to get flooding in areas not right on the waterway. So these are areas further upland from the water that is freshwater flooding. It is precipitation, but it's because of the increase in the water level where the storm sewer drains out. And in some places in Norfolk, actually, the tides will back up entirely through the storm system. So there are places where you can find fish on the street during high tide events. Okay, so now talking about sea level. So how do we know sea level is rising? Well, we've been measuring the sea level for a long time. The earliest tide gauges in the United States date back to the mid to late 1800s. In Virginia, we have a tide gauge in Norfolk, which dates back to 1929 or 1928. So as long as we have been measuring sea level rise, it has been rising, or we've been measuring sea level, it's been rising. But it's rising faster now, and that's the reason we're talking about it more now. So there's two ways we can measure sea level. One is with a tide gauge, okay? And so this is where our records, our long-term records come from. And these are measuring water relative to the land. They're measuring what we call local or relative sea level rise. And these are the same experience a person standing on the land would have, or the same experience a house that was built 100 years ago would have. Okay, so that's what we're getting from the tide gauges. And these are our long-term records. Now, satellite altimetry can measure the entire surface of the ocean. We've been doing that since 1992, which is actually not considered a long record in the world of sea level rise. That's considered a pretty short record. The good news is when we look at the long records from the tide gauge and we look at the shorter records from satellite altimetry, the global average is pretty much the same. So we're getting to the same answer. But we talk about global mean sea level rise, which is about 3.2 millimeters a year, as if that was something that was happening generally across the Earth. But actually, there's a lot of variation in sea level rise. So when we look at the results of satellite altimetry, this is what it looks like. So these are different colors, indicate different trends. So we can see this color is our 3.2 millimeters a year, our global average. But we can see there's places here which are rising at 8 millimeters a year. And then there are places here which are falling at 4 millimeters a year. So there's a lot of variation. And this is why when we talk about the tide gauges, we're talking about the local sea level rise. So we're talking about what's happening at this point, not what's happening on average around the globe. And there are a lot of things that actually affect what's happening at one particular point. So our global processes are driven mostly by temperature changes. So that is what we call steric changes. And this is as water heats up, it becomes more active, the molecules become more active, and they actually expand and take up more room. And so that causes an increase in the amount of space that the water takes up. And then the other one is we call eustatic, it's what you hear about a lot in the news. And this is the melting ice sheets where the ice is on the land and it melts and it comes off into the ocean. Less talked about, but this can also be water coming from underground aquifers that we draw up and we use in our houses or in industrial processing, and then we return them to the rivers instead of to the aquifers where they came from. So both of these things contribute to the kind of overall average global sea level rise. Relative sea level rise is a combination of that, okay, so our global mean sea level rise, and ocean dynamics, which vary across each of the oceans, gravitational shifts, and then vertical land movement. And the important thing to know here is that the only one that we have really direct control over is a portion of the vertical land movement. Okay, so this is the only one that we can easily change, and we can only change a portion of that. Anything else requires really big global changes. Okay, so the regional processes, these are the two different types of subsidence that we deal with in Virginia, which is vertical land movement. And in our case, the vertical land movement is that the land is subsiding, it's going down. Okay, so the water is rising relative to the land in addition to actually rising globally. So the two reasons, one is that there was an ice sheet in the last ice age that pressed down on the New England area. Because the continental plate is connected up there, Virginia actually bulged up at that time. The ice sheet didn't come down quite this far. So at that time, sea levels were relatively low in the Virginia area. As that ice sheet melted very slowly, the land started to rebound, and in the New England and north area. And in Virginia, the land started to sink. So we have sea level coming up, and then we have the land sinking, so we get a little bit higher sea level rise. The other big cause of subsidence is withdrawal of groundwater or hydrocarbons, so oil and gas. And in Virginia, we have a little bit of that issue. So this is an area up here at West Point. There's a paper mill up here, and this is one of the areas where there's been a little higher rates of subsidence. And at Franklin, we have a pulp mill, and this is one of the other areas where there's been, in the past, a little higher rate of subsidence. So this is the part that I said we actually can control. So if we stop withdrawing groundwater or hydrocarbons, we see that subsidence stop. And this was seen in Galveston, Texas. Actually, there was, back in the 60s, there was a lot of groundwater being withdrawn, and they were seeing like 10 inches of subsidence a year. It was huge. But as soon as they stopped withdrawing that amount of groundwater, the subsidence slowed. So there is some control over these processes. The last one is called the Atlantic Meridial Overturning Circulation. And this is they call it the ocean conveyor belt. Water heats up in the tropics and it moves up to the poles where it cools and it sinks and it's returned on the bottom of the ocean. And the part of this that comes by Virginia is called the Gulf Stream. It comes right off the mouth of the Chesapeake Bay where it makes a turn out into the ocean. And what has happened is the Gulf Stream has actually been slowing down. And as it slows down, it pulls less water away from the coast than it used to. So the Gulf Stream actually kind of bulges up. This is a graph. This is actually a graph of the Gulf Stream. And this is where it was like in 2000. And it was actually pulling, the water for this bulge came off of the coast of Virginia. And as it slowed down, it's pulling less water. And so now the water level is higher along the coastline. So we have all these things going on in Virginia. We don't just look at Virginia though. Every year I do a sea level rise report card for 32 stations around the United States and 5 in the Chesapeake Bay that look at how sea level has changed over that year and how it's affecting the long-term prognosis for sea level. So I'm going to show you a little bit what that looks like, just to put Norfolk in perspective. So Norfolk's the one here with the blue star. And we are coming up, it's hard to read off this graph, but it's like 5.5 millimeters a year that we're coming up. You can see that's higher than anything else on the East Coast. Okay, so we have the highest rate of rise on the East Coast. Now the Gulf Coast does have some areas in Louisiana and Texas with much higher rates of rise. And in Alaska, there's tectonic uplift of the land. So sea level is relatively falling where that tectonic uplift is happening. That's why these rates are so low over here. If we look at what this means for projected sea level rise in 2050, so how high is the water going to be in 2050? Because 5 millimeters a year doesn't sound like that much, but it's accelerating, okay? So every year that gets a little more. So by 2050, we expect it to be coming up 10 millimeters a year. And all those millimeters add up. So we're looking at, this is about 1.5 feet of sea level rise that we're looking at seeing along the Atlantic coast. The Gulf Coast, again, is a little bit higher, particularly in Rockport, Texas. If we look through the bay, the numbers are pretty similar for the lower bay stations. So this is Norfolk, Yorktown, Virginia, and Solomon's Island, Maryland. All have pretty similar rates as the top 3 lines on the graph here. Baltimore and Annapolis have slightly lower rates, and that's because they're further away from the influence of the ocean, and they get more influence from the Susquehanna. But if you look here, this is Annapolis, and Annapolis has been kind of taking off in the past few years. It's doing its own thing, leaving Baltimore behind. So what that means is the trend is accelerating quite quickly in Annapolis. So if we look out for the 2050 projections, we see that Annapolis is 52 centimeters. So it's actually slightly higher than the 2050 projection for Norfolk. But it's pretty consistent across the bay except for Maryland, or except for Baltimore. And if we want to put this in a longer term perspective, so what's going to happen in 2100, we have to move out to global climate models. So the work I've been doing is based on tide gauges. And the thing about tide gauges is it tells you what is actually happening at the site. So that's awesome. But also when you're projecting forward, you have to assume that processes in the future are going to stay the same as they've been in the past. Okay. And we know that's not a great that's not a great estimate going forward in the long term. So when we want to look out further than 2050, we need to move to global climate models. So these purple lines are from NOAA's global climate models. And so they assume different things happening. So different rates of carbon emission or ice sheets melting much more rapidly than expected. So this is the worst case scenario where there's a lot of heating and ice sheets are melting much faster than expected. And these scenarios here are ones that would require carbon emissions to be cut to get to, okay? So right now we're pretty close to NOAA's intermediate scenario. That's about what the tide gauge is suggesting. Virginia has chosen to pick the intermediate high scenario for planning. And one of the reasons for that is they were talking specifically about infrastructure, and it's cheaper to build a little bit higher than to be wrong. But the other reason is that ice sheets do seem to be melting faster than we expected. So there's reason to think we might be looking at a higher projection. Okay, so I wanted to just show you a little history here and explain why this is a rising matter. So I said, as long as we've been measuring sea level rise, it has been, as long as we've been measuring sea level, it has been rising. But we weren't really aware of it. We did actually know it was rising, but we weren't really worried about it. And I'm going to show you why. Okay, so this is the flooding, the hours of flooding that happen in downtown Norfolk, the Ghent area. And this series was put together by Dr. Larry Atkinson from Old Dominion University. Okay, and so flooding is the part we experience. Sea level rise is slow and it's lost in the daily tides. But when we see flooding happen, then we pay attention. Okay, so if we go back to 1928, which is when the tide gauge record starts, we see there's almost no flooding in Norfolk at all in 1928, 1930. In fact, when we go through 1958, we only have 2 years that have more than 2 days of flooding, right? So 362 days with no flooding. And then, you know, a couple of days with flooding occurring. So this is not something people are really going to worry about or be high on their radar. Okay, if we move out to 1985, what we can see is there are a few more years that have more than 2 days of flooding, and they are coming at a greater frequency. We can see that. And we've had 1 year with more than 3 days of flooding. So this is still not something we're terribly worried about. Maybe we've noticed there's a little more frequent flooding, but probably not even that. Okay, so if we extend this record out to today, though, it looks really different. So this is our 1 year with 3 days of flooding. And then this is our current record, right? This is what we're experiencing. That year with greater than 3 days of flooding, which looked extreme before, is now not only normal, it's low for normal. So flooding is becoming really apparent, and it's starting to impact people's ability to get to and from work. It's flooding their basements. It's impacting their ability to sell their houses. So now we're getting to a point where this sea level rise and precipitation flooding is starting to really affect us and impact us. It's getting a lot of attention. The good news is we actually have some pretty good predictive abilities now. So this helps us understand what the problem is going to be. We don't have to be unprepared for sea level rise. So this is sea level rise in the Dike Marsh area under the state planning guidelines, so the intermediate high scenario. So this is what the high water looks like today. And so this is the 2020 high water. This is what it's projected to look like in 2050 under that scenario. And this is what it will look like in 2100 under that same scenario. So this allows us to see where the problems are going to be and to prepare for it. When we look at planning for sea level rise and flooding, we have a lot of different questions. Some of them are for ones that individuals have. Some of them are ones that localities have. So individuals may wonder if their house is likely to flood in a storm event. They may wonder if they're still going to be able to get to their house in 20 years. The one people always ask me is, when should I sell my house? And then localities have some different ones. So they want to know about their infrastructure and how they can protect it and how they can make it resilient. And also, what are the legal authorities they have to deal with those issues? So we're not going to talk about it today, but we actually have a great resource to look at these. So this is a collaborative effort with a number of different organizations, including William & Mary Law School. Elizabeth contributed quite a bit to this. And so .va is giving us the forecasts that we need to prepare, the adaptations that we can look at to help deal with that, maps, tools, and data that can be used by localities or individuals, and planning and policy information. And so with that, I'm going to hand it over to you, Elizabeth.
Okay, I'm going to share my screen unless, Rob, did you want to do a question?
No, why don't we go ahead and we'll hold questions to the end. So if you do have a question, please submit it to the Q&A and we'll pull from those after Elizabeth's discussion. Thank you.
All right. Hopefully you all can see my screen. I too chose a photo from Norfolk area that's flooding. And as usual, Dr. Mitchell did a great job of putting complicated science into common terms, but all of you English and history majors out there can now relax. No more isostatic glacial rebound in my talk. Mine's going to focus much more on law and policy and the challenges to planning for coastal resilience. Just to let you know what my center is, the Virginia Coastal Policy Center is part of the clinical program at William & Mary Law School, but we're not a litigation clinic like the other clinics. We are a policy clinic. And that means that we do research and develop white papers on various law and policy questions about coastal issues, ranging from aquaculture to wetlands and water quality and cleaning up the Chesapeake Bay to climate change, which is what we're talking about particularly today. So again, this is some of the typical, unfortunately, flooding that we're seeing more and more of in the Hampton Roads area. So let's talk about a few of the challenges as we plan for resilience. The big one, of course, is show me the money, funding. There's not enough of it. We can't possibly pay to save everything that we want to save from this flooding. And it's expensive if you choose to hard armor things and build seawalls and try to protect communities, it's quite expensive. If you decide to relocate portions of your community, it's quite expensive. And the feds are not going to save us. We have some funding through the Corps of Engineers, but it takes a long time to get that funding and it's limited. There's not enough. You have to, many people don't realize you have to go through congressional approval for a study and then appropriation to do the study. And then you have to have congressional approval for an actual resilience measure that they want to build, a levee or a seawall, and then the appropriation. And so it takes a long time. FEMA, the Federal Emergency Management Agency, as you all know, has many, many different things that it has to respond to. Earthquakes and wildfires in addition to flooding events. And they just don't have enough money. The subsidized flood insurance program, the National Flood Insurance Program, does not accurately reflect the risk of loss. And so there are inadequate premiums to pay for all of the different claims. The NFIP, the National Flood Insurance Program, was already over $24 billion, that's with a B, in debt before hurricanes Harvey, Irma, and Maria even hit. And so they had to go to the Treasury Department. They had to have Congress step in and get part of their debt canceled so that they could afford to pay out claims. And the FEMA flood maps are not predictive. They don't incorporate the data that Molly just showed us to talk about future flood risk. It looks back at historical flooding, so they don't encompass all of the risk. And a lot of these maps are out of date. And so for all of these reasons, we don't have enough money. We have recurrently flooding properties that people stay in because they can't afford to move. It's very sad. And they, until they're bought out by a program, they are stuck there. Another problem is that our local governments are overly reliant on real estate property tax revenue to fund their programs. And without a source of other funding, they allow development in flood-prone areas way too often. And it's because they need a source of revenue. Until we as a society come up with another additional source of funding for them, that's a fact of life. Another issue is our election cycle, our short election cycle. At the local level, government officials are elected for a short term. In Virginia, our House of Delegates, they're elected for 2-year cycles. So that is not enough time to get our elected officials fully up to speed and have them get any traction if they are trying to address our different flooding needs and risks. And so that too contributes to the problem. In addition, it's unpopular, frankly, to run for office and say, I'm running to raise your taxes today to help pay for improvements that will make the world safer and drier for our children in the future. That's not a popular line. But the truth is, as you've seen from these photos and from Molly's data, the flooding is here with us today, and we need to address it today. I always tell my law students that you thought you signed up for a law class, but really it's more like Psychology 101, because you're going to learn all about how bad we are at planning ahead. The needs of today demand our attention and our funding. Transportation, schools, public safety, all of that, they're very necessary and we need to address them, but we need to get something that gets our attention to enable us to put the money that we need to into the investments to make our infrastructure resilient and to plan for things. I love a quote from Kurt Vonnegut. He said, one thing that no cabinet has ever had is a secretary of the future. And there are no plans at all for my grandchildren and my great-grandchildren. And it's very true. So we require something to grab our attention and to also then grab our resources. And part of that is we always say, it's always been okay. It'll be okay again, but now it's not. And I want to share with you a personal story that brings it home. And it's about Louisiana, where I have some family. And back in August of 2016, there was an unnamed storm event. And the reason that's important is that it wasn't a hurricane being tracked on anyone's radar. We didn't have Jim Cantori from the Weather Channel clutching the lamppost on site with a television crew. It was just a rainstorm that hovered for 5 days, and it completely overwhelmed their stormwater infrastructure, and the rivers overflowed. We found out about it because my niece posted on Facebook early Saturday morning, I have water coming in under my door. And she had about 9 inches of fairly clean stormwater from the overflowing stormwater system and had to rebuild the interior of her house and her floors. The other niece got 6 feet of muddy river water and fish on her windowsills. So the community was slammed by 2 different kinds of flooding, all from this extended precipitation event, which, as Molly's data has shown you, they're predicting more and more increasing intense precipitation events. And one of the saddest parts about this was that the local elected officials, in an effort to save the residents' money, had pushed FEMA to redraw the maps to have fewer people required to buy flood insurance. So some people had stopped paying their flood insurance premiums about a month before the storm hit, and then they were devastated and they lost everything. I took this photo because it shows you that that became a priority thing. You know, buy this house, it did not flood. That was the big line that they touted. So it was a culmination of sad events. And another part of it was the evacuation. My parents were there. My father, being elderly, had a walker. They came through with an elevated National Guard truck to evacuate everyone. And he couldn't get up in the truck. And so they left him and my mother at their house and said, we'll have to figure out something else, because they were trying to figure it out as they did it. And so luckily, locally, a lot of the residents jumped into kayaks and canoes and saved elderly people through what they called the Cajun Navy. Thank heavens my parents didn't need that. It came to their door. But the point is, I'm not slamming them in particular, because so many of our communities are not prepared. We are not planning. We haven't thought through all of that evacuation, the steps required. And it was actually lucky they didn't go, because a number of residents were taken to a church that also then flooded, and they had to be evacuated with a helicopter from standing on the altar. So that is just a very detailed example of what we're facing in communities around our country if we don't plan as we need to for these events. And it's not just in America. A survey recently of 800 cities around the world found that about almost 43% of them do not even have a plan to adapt to impacts of global heating. And about 25% of them cited budgetary restraints as the key reason. So again, funding is key. We don't have enough of it, and we need to figure out a way to fund all of the measures that we need to take. So another challenge is the loss of the local tax base. We have this conflict right now where shoreline property often is the premium. It's the most highly sought after for the waterfront homes, particularly in rural areas. That's the most expensive real estate and therefore generates the most property tax revenue. It's also sought after for water dependent businesses like marinas and aquaculture operations, and for resource and habitat protection. We need marshes along our shoreline as buffers for flooding. That's where they are located. So there's a conflict there, and a lot of localities are scared of losing their local tax base. They're scared of once you lose too many residents, the businesses will leave, and then you've lost your revenue to become more resilient, and it becomes a downward spiral. And that's what we're trying to avoid with our waterfront communities and our flood-prone communities. There's also a problem with the loss of culture or heritage, your family ties. No one wants to leave a community that your family has been in for generations. It's heartbreaking, and it takes money. Many people cannot afford to do it, and they don't have any place to go, and they can't even imagine themselves somewhere else. So that's another hump we have to get over. We have to be able to envision new safe communities nearby that they can go to. Some communities are doing innovative things. California right now is considering legislation to provide funding for localities, loans where they can go in and buy properties along the coast that are at risk of flooding, and then rent them out for a while and then leave when they have to, when it gets to the point where they can't be used anymore. They call it a buy, rent, retreat approach. So we need to think about how to work with families, whether they get a life estate and they get to stay there for the rest of their life and it doesn't go to their children. There are different approaches discussed by different communities, but we have to deal with that. The repeated rebuilding funded by the NFIP, I'm going to talk about in a moment, a way out of the woods, hopefully, from FEMA that they've come up with, but it's been a serious problem that we keep putting good money after bad and rebuilding communities that are already flood prone, below sea level, subject to increased flooding because of the data that Molly showed you. The Dillon Rule is a rule of statutory construction. We are a Dillon Rule state in Virginia, and what it means in a nutshell is that local governments cannot do anything unless they're authorized to do so by the General Assembly. And that can serve as a constraint on our communities in Virginia. Sometimes local governments have said, we're not sure that we have the authority to do something innovative to deal with this flooding. The city of Norfolk is an exception. They have redone their comprehensive plan to say we're going to funnel development towards the higher ground, and we're going to use our zoning ordinance and overlay districts to incentivize it. They went for a carrot versus a stick. So they said to developers, if you get control over low-lying flood-prone property that you either purchase or get an easement over it in perpetuity, then we will help to expedite your development on higher ground. And it's an incentive to enable the market to drive the development to higher ground. But they're relying, by the way, on their city charter as well as any kind of statutory authority. So there's a mix of causes of this flooding. As Molly has noted, right, sea level rise is a big one, increasingly severe storm events, but also outdated stormwater infrastructure is another one. And increased development brings increased what we call impervious cover, roofs and parking lots and driveways. So the stormwater runs off at greater volumes. So with a mix of causes, there's a mix of remedies that we need to use to address it. A good example is Hurricane Matthew, which made landfall not in Virginia at all. It made landfall in South Carolina, and yet it still wreaked some havoc here, even though it was offshore. And it had 14 to 18 inches of rain in less than 12 hours, but the stormwater infrastructure was already waterlogged from a tropical storm that had just gone through. So at least 1,400 homes in Virginia Beach were damaged, more than 600 of which were in one neighborhood that had stormwater infrastructure from the 1980s that the city was already aware needed to be upgraded. So it's a good example. It doesn't have to be a direct hit from a hurricane. It can be an offshore storm. It can be a nor'easter that when the wind's blowing right and the moon is full, or if there's a king tide, it creates even more problem. So some examples of how communities are responding. Miami, Florida has a lot of expensive real estate. And so therefore, they have felt like it's worthwhile to invest in some hard infrastructure, gray infrastructure to protect things. They're raising up roads and they're building 80 pump houses, and it's costing them $400 to $500 million, paid for with stormwater fees and with bonds. But besides the high cost, some of the businesses are ending up below the road level, as you can see in this photograph, and it's problematic for them. This one gentleman had problems at first when he was flooding because FEMA came back and said, no, you are like a basement and we are not going to be paying for flooding basements. And so he had to negotiate that. So it creates all kinds of new and innovative problems. It's also hard on historic communities, historic areas that need to be preserved. And Jamestown, Virginia is one that you all are very familiar with, having gone to William and Mary right down the road. I'm sure you visited while you were in school. Mandeville, Louisiana, and Newport, Rhode Island are taking 3 different approaches that I want to talk about with you. So for these sensitive areas, whether they're historically sensitive or culturally sensitive, like tribal areas, there are really 3 alternatives, and they're all limited, and they're all costly, and they're all really difficult choices. None of them is a perfect fit. You can either relocate buildings and risk losing the historic status. If it's an old home with an English basement, you can lose that in the foundation, you lose the outbuildings, you lose the original site. You can abandon the properties to flood over time and be destroyed. That's not a good choice for anyone. Or you can raise up the buildings and lose some of the community's character. So it's important, if you decide to stay in place with a community like that, that you have some kind of standards in place. And Mandeville, Louisiana is a community on the north shore of Lake Pontchartrain. It's where people in New Orleans back in the day built their summer homes. And they have come up with some design standards as they realized with the flooding, we are raising up our houses more and more. We don't want the ugly garages facing the street. We don't want the steps that come down, huge steps right to the street. So they've come up with some design standards, and that's one way to do it. Jamestown, it's interesting because Hurricane Isabel risked damaging 900,000 artifacts at Jamestown. And you might think, how is that possible? But it's not just the artifacts in their exhibit buildings. It's also the ones in the soil still. And the archaeologists traditionally don't like to disturb things unless they have to, because they wait to see if they can get better technology over time that's less intrusive and less disturbing. So now they're having to rethink that, because with rising flooding and sea level, they are more and more facing inundation. The site itself is flooding, the shoreline's eroding. And by 2100, that NOAA intermediate curve that Molly just showed us suggests that the entirety of the glass house at Jamestown will be submerged. Parts of the Colonial Parkway near the settlement will be close to being submerged. And the extreme estimates show the fort will be nearly at the water's edge during that time. So the James River level is 4 feet higher than it was during the colonial era because of the land subsidence as well as the sea level rise. And the elevation of Jamestown is only 3 to 7 feet. So it's truly in danger. On the left of the screen, you'll see a flyer for an event. There's a series of events called Keeping History Above Water. They did it in Annapolis, Newport, Rhode Island, St. Augustine, Florida. And it's where they bring together historic preservationists and they try to figure out what can we do to address areas that are getting more and more flooded and suffering from the impacts of climate change. So up in Newport, Rhode Island, they asked students from the Rhode Island School of Design to come up with ideas for things to do to address these climate change impacts. And they came up with one called the Memory Trace Project, where essentially current houses would be replaced with concrete houses with an elevated pathway showing you surrounding walls surrounding them in this original street grid. So you can look down from above and see an aerial view of what the town looked like. So obviously extremely costly, not particularly practical, but it shows the kind of out of the box thinking that they're trying to encourage to deal with this existential threat and preserve the memory of what we have. So one thing that we could do is green infrastructure, use of natural features, marshes as flood buffers, marshes and wetlands. The Dutch know more about living with the water than anyone else in the world. So they created a program called the Dutch Dialogues. They've gone to various cities around the country. They've gone to the New York, New Jersey area, Hampton and Norfolk in Virginia, New Orleans, and they advise on how to live and thrive with the water. For Hampton and for New Orleans, they advised creating canals, for example, to create value from the water. You have green spaces around them with hiking trails and biking trails. Communities can look down over the water and have a nice view. Creation of living coastlines out of rocks and oyster shells and natural materials can stop shoreline erosion and create more resilience. For example, the Beaufort, North Carolina living shoreline fared better in Hurricane Florence than the coast that had the hard seawalls. They had less erosion. And wetlands and marshes are key flooding buffers. So we have to have the room for them to migrate upland as the sea level rises. A 2017 study showed that $625 million were saved in property damage from Superstorm Sandy due to marshes. So they are an important thing for us to preserve. A couple other examples for you. Rotterdam in the Netherlands, they have so much of the country that is below sea level. They have, in fact, a reservoir where they held the World Rowing Championships in 2016 that's 20 feet below sea level. But this is the Spangen Plaza, and I apologize to anyone who is Dutch who's in attendance because I probably just butchered that, but the Spangen Neighborhood Plaza in Rotterdam. You can see that they have a basketball court, they have a fountain, they have a garden, and it also serves as a retention pond in a flood event. The mayor noted that if the water comes in from either the rivers or from the sea, then they can at most evacuate about 15 out of 100 people. So it's not really an option. So they can escape only into high buildings. And so they create this as a stormwater overflow so they can learn to live with the water. Oxford, Maryland, closer by on the Eastern Shore, they're expanding their existing stormwater swales and creating stormwater retention ponds in green areas so that they hold the rainfall and they provide wildlife habitat and green space. And they're also talking about perhaps getting easements for retention of stormwater on private land as well to keep the community from flooding. Up in New York, another example, they buy out houses and they let the areas, they take them down and they let the areas go back to nature. This is Oakwood Beach, the first New York town abandoned to sea level rise. They actually have a combination plan. They have a 4.3 mile seawall that they're building, and they're also doing managed retreat where they are buying out. They've already purchased nearly 400 houses at a cost of $160 million funded by the state of New York. So they're pursuing managed retreat, and so is New Jersey. They have a buyout program called Blue Acres, where they purchase homes from willing buyers and they purchase them at pre-disaster price. This was after Hurricane Sandy. They got a lot of funding to do this program, about $300 million. And they go and pay a price that is the equivalent of what their pre-storm value was because they don't want to lose out on this purchase. And then they provide a buffer. That area provides a buffer near the coast for other properties. A very successful program. So what are we doing about all of this? Well, at the state level, interestingly enough, we have a code provision that requires notification of property owners by their locality if there's a change to the FEMA flood map that affects their property. And I say that it's interesting because our students just did a research paper on this semester because the flood management program at the state level asked us, they said, we've got this statute. We're not sure localities are actually complying with it, and we're not really sure why it's on the books, what's going on. So our students did some research and found it was because of Northern Virginia that there was a bad storm event in which a neighborhood in Alexandria became quite flooded. And a number of the constituents went to the then delegate and said, we want to have some kind of notification. We had no idea the flood maps had changed and we didn't have flood insurance. So it's required that localities notify residents when there's a change. And that actually, that same storm spawned a lawsuit, Livingston V Taylor, in which the Supreme Court of Virginia held the Virginia Department of Transportation liable because they diverted a portion of Cameron Run, a naturally occurring stream in the Alexandria area, to be part of the stormwater drainage system for the Capitol Beltway, and then did not maintain it. And so the court said a government can be held liable for not maintaining their stormwater infrastructure. That got everyone's attention. Another thing in Virginia, there's a code section that requires localities in the Hampton Roads area to incorporate strategies to address sea level rise into their comprehensive plans. That's a great idea, should be done throughout the coastal area. We are now in the process of developing the first Virginia Coastal Resilience Master Plan. Louisiana has done one, Texas, North Carolina. We are working on ours. It's due in November. I serve on that technical advisory committee, and I can tell you that there are so many subcommittees and we're doing a lot of work and trying hard to get it done by November. And we're using as funding for a lot of these projects, the Virginia Community Flood Preparedness Fund, which is a new funding source created by auction proceeds from the Regional Greenhouse Gas Initiative that Virginia just joined recently. In Maryland, the the legislature has authorized local governments to establish these resilience authorities, and they can decide how to fund them to pursue resilience projects. So Maryland, for those of you in the DC area from Maryland, they're working on this too. What about at the federal level? Well, the Chesapeake Bay program, which Dr. Mitchell and I are both very active with, has a climate resilience work group. And we focus on those three criteria that Molly outlined of sea level rise, increasing precipitation and severe storm events and temperature. And so a program that's traditionally been all about the water quality in the Bay is more and more realizing we have to address climate change too. We can't avoid it. FEMA Risk Rating 2.0. This is what I was mentioning earlier, is an update to the National Flood Insurance Program. The first update to the risk rating method that they use in 50 years. It's a really important change. And FEMA is touting it as a much more equitable approach because they consider the rebuilding costs of a property, and they can equitably distribute the premiums across all of their policyholders based on both the home value and a property's unique flood risk. So they're anticipating that beginning October 1st, the NFIP policies will be subject to this new approach, and existing policyholders who are eligible for renewal will be able to take advantage of immediate decreases in their premiums. So that's great. They think that about 23% of the current policyholders will see a premium decrease. About 66% will see a $0 to $10 increase in their premium per month. 7% of them a $10 to $20 increase per month, and 4% over $20 per month increase. So you can see they're really trying to distribute that cost more equitably and reflect the risk more. Also new last year was a new grant program that FEMA introduced, Building Resilient Infrastructure in Communities. And that's exciting because it's for the first time, it's a grant program to provide pre-disaster dollars to help communities plan, including, if necessary, plan for relocation of some parts of the community away from flooding areas. And they do stress the importance of incorporating nature-based features that I just talked about. And the Corps of Engineers is now requiring localities to use eminent domain if they're going to qualify for core funding for buyout of homes. They're trying to enable managed retreat when it's necessary. And there are a couple of executive orders at the federal level, and I'm not going to go into them much because we're about to run out of time, but needless to say, there's a lot of change at the federal level, creating, asking the federal agencies to look at their regulations to make sure that they address climate issues. And the private sector has also begun to pay attention to this. Moody's has said, we're looking at your responses to climate change when we're doing your credit rating localities. BlackRock, investment firm, pressuring companies to address climate change. Potential blue lining by banks is something that everyone's worried about, where they might just wall off an area and say, we're not going to do lending there anymore, and people won't be able to sell their properties. And Realtor.com is now disclosing flooding risk. So that's a big change on their listings. So finally, what do we need? Funding, public and private funding to get this done. Planning, for all of it, transportation, housing, these buffer areas and green space, and sometimes, frankly, we have to plan for strategic relocation. I know that we don't like to talk about managed retreat in some places. Some people think it's un-American, it implies defeat, but it's something we've been doing since America started. Farmers moved west as the soil was exhausted. Jamestown had originally the first church there, and because the residents got tired of being cut off and having to go through floodwaters occasionally, they built the church on the Main, not far away. So we've been doing this since we got here. And we just need to embrace that, take it into account, and try to address this as best we can. And as we do that, we have to take into account our vulnerable communities and make sure they're not priced out of affordable housing, safe housing. Paradise, California, for example, destroyed famously by wildfire. They had a serious issue afterwards with wealthy people coming in and buying up the lots from people that were just desperate to get out, and also people that couldn't afford to rebuild housing that was safer because the old wooden sheds were no longer allowed there. So that's what you don't want to have happen, kind of a form of climate gentrification. So what do we need? Most of all is education. I always end with that last because that's key. We have to educate ourselves on the risk by listening to people like Dr. Mitchell, tell our neighbors about it, talk to our elected officials, tell them we want them to vote in support of things that address these flooding issues, support flood history disclosure laws, especially like down in Norfolk, a transient area where we have so many people coming to the naval base. They need to know before they buy a house whether or not it's flooding recurrently. In the National Flood Insurance Program, you can check your community rating system rating, which gives you discounts on flood insurance. So there are things that we can do to equip ourselves and to create the political will to address this challenge. Thanks. I'm going to hand it back to Rob now.
Thank you both for that really fascinating discussion. I think you've done a great job highlighting the importance of both good science and good policy to address these issues. And I think also brought up really important ideas about how we're going to have to think outside the box for multidisciplinary, innovative ideas at all scales to address climate change and sea level rise. We do have, I know we're pushing up against 7 o'clock. If people would like to stay, I know we're going to have questions. We have some in the Q&A. So I'd like to pose some questions if Molly and Elizabeth, if you're okay spending a little more time with us.
Absolutely.
Excellent. The first one is about shoreline restoration and the role shoreline restoration is going to play in mitigating the impact of sea level rise. It's been a focus of the Chesapeake Bay's program and came out in one of their recent reports. And so how much of a role can shoreline restoration play in mitigating the effects of sea level rise? And does that change when we're talking about urban areas versus more rural areas along the shoreline?
Yeah, that's a really good question. So the role of shoreline restoration is predominantly to buy time. Okay. So it does provide some protection against storm surge and wave energy and helps reduce those. It protects the shoreline against erosion, so it keeps distance between buildings or roads and the water line. But we do talk a lot about, and this is a really good point, we do talk a lot about marshes and beaches being resilient systems. And they are resilient if they have room and space to move because they're also dynamic systems. So if we box them in between a levee and the water, they are going to get squeezed out and they're going to disappear. If we allow them room to move, then they continue to move and they continue to provide the storm benefits, but also the habitat and the water quality benefits that go along with it. So one of the things that they're looking at down in Norfolk is whether there's a way to kind of create easements that as marshes migrate onto people's lands, that triggers buyouts. Because if we don't do that, if we barricade and block off the houses instead, if we don't use that as a way to retreat, we're going to end up with less of these natural systems, even with the ones we create.
Excellent. Elizabeth, go ahead.
I was just going to add one thing, which is one of our challenges in Virginia and in Maryland, but our coastline is so much privately owned.
Mhm.
You know, a lot of these grant dollars are aimed at public sites, and we need to figure out, that's why I always end with education. It's the landowner themselves who can figure out that I need to leave room for the marsh to migrate. And so I just want to point out, it complicates it a lot.
I think that brings up a really good next question is, what is the role of the individual here? And how can an individual, whether it's someone living right on the shore or someone living in an urban area, help to play a role in the mitigation of climate change and more particularly sea level rise?
I think I kind of ended with that slide, right? I think Molly's going to agree with me that I always say education, and it's not because I'm a professor. It's because educating yourself and your neighbors about the risk is key. Using that ADAPT VA site is a great way to start, that Molly was pointing out, because you can at least go down to the address level and see what's expected for my community and talk about how do we preserve the marshes as a buffer? How do we lay out the community, get involved in the planning process for the community? How do we lay out the community to provide those pathways for the green infrastructure, for the uplands migration of the wetlands, and to keep development out of harm's way? An educated community resident, an educated citizen is less likely to put themselves in harm's way and to buy the property in the flood prone area, right? If they know that that is a real risk. And avoidance is cheaper than trying to rebuild or regroup after you're there.
Yeah, and I think another important piece of that is engagement, because, you know, Elizabeth said it's a hard pitch to go out there and say, vote for me because I'm going to raise your taxes today to protect these buildings 30 years from now. But if people are out there and engaged, and that's what they're asking their public officials to do, then that's different. Then that becomes a good pitch for getting elected instead of a really bad pitch.
Excellent. But another really great question. It's likely that as sea level rise, it's going to impact local waterways, and we're going to see increased pollution in local waterways that might affect even drinking water. So are there any notable infrastructure policy considerations regarding climate-related water quality concerns?
So the climate resiliency work group that I mentioned earlier with the Bay program has definitely taken on a lens of multiple benefits. And we see that a lot in our discussions. As we're developing the Coastal Resilience Master Plan for Virginia, we talk a lot about multiple benefits. And by that, we mean marshes can provide habitat and shoreline stabilization, but they also can filter your water and provide water quality benefits. And are there stormwater BMP, best management practices that we can put in place that do that filter the water and improve the water quality while also providing flooding buffer benefits? It's absolutely true that as industrial areas, a lot of our, you know, we saw it some years ago with the coal ash ponds being on the waterfront and making the news. But so much of our storage, our wastewater treatment plants, et cetera, are at the waterfront. And so there is a risk as areas become inundated that chemicals can get in the water. I mean, we saw that in Harvey, in Houston, Hurricane Harvey, and the power went out and the generators went out, that so many sources of pollutants were then became dangerous, and it was a risk of getting them distributed. So that has to be part of our policy planning. There's been a couple reports about toxic pollutants and more need to track them for that reason. But that's still an evolving area, I think, of planning. As that's another thing a community can do is they look at the predictive data and they say, where do we want our industrial sites? Maybe we don't want them near the water anymore. You know, maybe we try to move them back over time.
Excellent. I want to turn to Elizabeth, one point that you made on your slide, that quote, we can't save everything, and that there's going to be a significant amount of planning and decision-making going on in the coming years around climate change and sea level rise. But how do we ensure that that planning is equitable and just and inclusive? Because oftentimes you can imagine a scenario where traditionally excluded voices are not being considered in the planning process because they're not raising their voices or being heard when it comes to making these decisions.
That's a great question, Rob. You know, that's one thing we're trying to do in this Coastal Resilience Master Plan effort is make sure that the more vulnerable, whether it's socially vulnerable, physically vulnerable, Those who don't have a voice at the table usually, including tribal voices, are included in this effort. It's key because they haven't been in the past. You're exactly right. And that's why I showed that slide about Paradise, California, that it's so easy to price people, if we don't watch it, to price people out of safe housing. We have to make sure that I like to call it our communities of tomorrow, that we envision, kind of like Rotterdam, that have green spaces to hold floodwaters when necessary. The city of Hampton with its canals, same thing through their resilient Hampton effort. We have to make sure the affordable housing is there for our residents because otherwise they could easily be priced out of it. And it has to be a main goal throughout the process.
But yeah, I'm curious even about that process you mentioned of blue lining areas by the banks. That seems like it also has the potential of really harming people who cannot afford to be harmed in that way. So how is that something like that going to be addressed?
So, there are a number of really bad scenarios that could happen here. Let's just be honest, right? I hate to say that, but in some areas, this is an existential threat eventually. And a community is not completely changed overnight. It takes time. And I fully get that. I mean, you can blithely say, oh, let's plan to move our industrial area back off the water. That doesn't happen overnight, and it's not inexpensive. But look what Norfolk did. They laid out this aspirational comprehensive plan and said, we're going to push things over to here because it's higher ground ultimately. But in some cases, someone's going to be left holding the bag. There's going to be that house that you can't flip it one more time because no one's going to buy it because they've seen the access roads flood too many times, or your septic system has been inundated too many times and it won't work, and the ground just won't perk anymore. So there's going to be economic loss. It's going to be bad for some people, let's face it. But the more that we can take into account economically vulnerable communities in these grant programs, that's another thing. I was very excited the other day to hear that one of my Dynamite student teams wrote a paper analyzing cost benefit analyses in these various federal grant programs and noted that they didn't benefit those who were less wealthy. The more wealthy were able to, their properties could pass the cost benefit analysis more easily. So there's been a lot of public dollars spent to protect some higher end properties. And so our Virginia Department of Emergency Management is revising how they look at these different grant proposals to take into account things like that. So that was exciting news. So I think the more that we raise that as an issue and flag it for these grant programs, the more that will help.
Excellent, excellent. And it seems like people are hanging on. Molly and Elizabeth, are you okay answering a few more questions? Because I'm certainly really enjoying this conversation, and I think others are and would like to continue if you're okay with that.
Sure.
Great. Molly, I want to turn to you with a bit of a data science question. Thinking about the models, one, you mentioned using global scale models for the longer term projections, but how well do those scale to the local level? And second, as you're now able to compare predictive models to what's actually happening on the ground, how well do those predictive models tell us what we're seeing today?
Yeah, so all of the global scale models that are then brought down to a local scale, so all of those climate models, the predictive models, when they're brought down to a local scale, they are actually, what they do is they use a model to do what they call hindcasting. So they take the model and they create a old data set from the model, and then they compare it to the actual data. And then they can shift any difference between the model over that data. And so then they know what to shift the future scenarios by. So there is work done like that. And that's true of all the tide gauge stuff. So the global climate models actually predict much, much lower sea level rise than what you see coming out of NOAA. So what NOAA did was they looked at what's happening at the tide gauges and they related that. So what was happening, the change expected, okay, by the global climate models. So there is a lot of kind of ground truthing there. Now, having said that, when we talk about something like precipitation, we're talking in kind of generalizations. Okay, so there'll be more high intensity events. Putting an actual number on it is hard. And that's because we can't tell you, if it's going to rain 3 days from now over your house, right? We can tell you there's a high probability of rain. We can tell you within a month you're likely to get 3 rainstorms, right? But we can't tell you too specifically. So when we talk about things like precipitation, which are complicated by weather patterns, then we're looking for the generalization. We know there are going to be more high intensity events. We don't know if it's going to be 10 or 20 events.
Thank you. Here's a really interesting question. So obviously we're going to have to move structures away from coastal areas. What's going to happen to all the junk left behind, the septic tanks, gas lines? Is that just going to stay there and be buried by water and will just become part of the ocean system?
That sounds like a legal question, Elizabeth.
I was gonna say, what a terrible, good question. And I say terrible because it's a very appropriate question. Yes, I mean, there are, if you look at some beachfront communities, Nags Head had some, there are some houses that have had to back off from the waterfront already. And sometimes you see the septic pipe sticking up out of the sand, which is really lovely. So the problem is that private property ownership, the lines of property ownership are going to shift over time as the sea level rises. So in Virginia, we are a mean low water state, meaning that private property owners own down to the mean low water mark, and past that is the Commonwealth's bottom land. And so there's a lot of question up in the air right now about what happens, and a lot of localities that are scared they're going to be left holding the bag, having to clear out these ramshackle homes that have been abandoned because they are a public safety and health hazard, and the septic systems, much less anything, chemicals left stored in the garage. I mean, you name it. So it's a serious issue. And that's one reason why a lot of localities are worried about this as well. They don't want to be left holding the bag with all those costs. You want to be able to force the property owner to pay to take down the home. Sometimes they just abandon and leave, right? It's a serious cost and legal issue, both for localities, yeah.
Boy, interesting. I want to turn to the private sector for a moment. And Elizabeth, you brought this up in your discussion, but the question comes in as, are there any state or federal funding resources to support venture capitalists or risk capital to invest in resilience more actively?
Oh, that's a good question. We would love it. Please invest in Virginia, please, please. It's interesting because states that have resilience plans and efforts underway, it's often, unfortunately, storm triggered funding. We always joke morbidly in Virginia that we like Louisiana's funding. We really don't like the reasons why they have it, because they had the BP oil spill and they had Hurricane Katrina. So they got, and so many people say, all it will take is one good storm in Virginia and we'll get some federal dollars to come, which is a horrible alternative. Superstorm Sandy brought a lot of funding to that area. There are also some charitable foundations that have stepped forward, the Walton Foundation, Kresge, that have done the Baton Rouge Area Foundation in Louisiana. We don't have a foundation here in Virginia knocking at our door to help pay for this. So we would love to see private capital come in. And that is something that actually we've been talking about with this master plan effort, that we really need to figure out, how do we incentivize that? So I would love to partner with anyone who wants to have those conversations to figure that out. I actually chair the finance subcommittee for the master plan effort. So I'm totally serious. If somebody wants to contact me and talk about it, I would love to, because we need to encourage that and figure out the buttons to push, the carrots to offer, the incentives to get private investment in there. Yeah.
Excellent, excellent. And one more coming in from the Q&A. Why do electorates convince locals that they don't need flood insurance? So the example that you gave about Louisiana. And then what alternatives do you suggest to communities who rely on drawing groundwater or hydrocarbons in the face of sea level rise?
So when it comes to the flood insurance, it's frankly penny wise and dollar foolish. It's an attempt to say, oh, residents, look, you don't have to pay for flood insurance on top of your mortgage payment. But as that example showed, it costs a whole lot more. It's worth every dollar, right? To protect your home and your possessions. And the fact that they're redoing the NFIP with risk rating 2.0 to make it more accurately reflect the true cost of the loss, the potential loss, the risk, will help to fund the program. So yeah, that when you ask why do local officials do that, that's why. That it's to try to save the dollars today. And I fully understand that there are many communities where, you know, every dollar counts. That's why they're doing it. They're not trying to throw their community residents into unsafe situations. You know, they just don't realize, I think, the full extent of what they're doing. And then what was the second part of the question, Rob?
It was just about the use of drawing groundwater and the impact, and even hydrocarbons, such as removing oil, and the impact that could have on climate change. And are there alternatives to that?
So there's not a lot of, I mean, if your economy is based on withdrawing oil, or there's not a lot of alternative to that. I mean, it would be shifting the economy, right? Would be the big alternative. However, there is a project, there's one in Hampton Roads called the Swift Project, but this has also been done out in California and parts of the Gulf Coast, where they are injecting treated sewage water back into the ground. And so the idea behind that is that the water or the hydrocarbons actually take up space in the ground. And as you pull them out, the layers above collapse down to, you know, because there's nothing holding up anymore. And so the idea is to inject the sewage back into the ground. Well, it's treated, okay. Potable levels, okay, back into the ground. And so that will take up the space of whatever's being removed. And so that's, has been, it's early still, but the SWIFT project's been fairly successful at seeing the subsidence, like not moving too much, but whether that can be scaled up to a big level is a question. So right now we're talking about a very small scale. So you're injecting it at one site and you're seeing an effect, you know, in the immediate area. When you're looking at like the Gulf Coast, where they're withdrawing a ton of oil and gas, you'd have to do pretty big scale to offset that.
So one thing that might be helpful for all of you non-sciencey people out there, we're talking to a liberal arts crowd too, that I thought when I first started working with these groundwater issues, that a groundwater aquifer was a big pool of water underground, but it's not. It's saturated sediments. And so it comes in layers. You can have a clay layer, you can have sandy layers, rocky. And the problem is that once you pull that groundwater out of the ground and it subsides and flattens, the sandy layers can be expanded again, but the clay layers cannot. So this SWIFT project that Molly mentioned, the Sustainable Water Initiative for Tomorrow, is injecting, we like to call it wastewater, or septic water sounds terrible, but yeah, they do it much more directly in California. But it can expand some of those layers and it can stop the land subsidence and maybe counteract some, but we can't fully counteract it with just that. So we do need to find other methods to help with that.
Excellent. And in the interest of time, I'm going to limit it to one more question. And the question that I want to pose to both of you comes a little bit from the conservation community because of the challenges we've seen just getting people on board with this idea that the climate is changing and sea level is rising, in part because it happens slowly and it happens in other places. But this example that you start off with, the flooding of Norfolk streets on sunny days, must be a real sort of shock to the system. And I'm wondering how something like that changes the perception of climate change and sea level rise, not just in Norfolk, but around the country and places where they may be not potentially seeing those immediate impacts on a daily basis.
Well, we have Norfolk Naval Base, the largest naval base in the world. And one impact is that, the Navy, a priority is bringing their personnel to their base, right? They can hard armor all they want around the base itself, but they've got to bring their personnel in and their utilities, et cetera. So the fact that the roads are flooding around the base in Norfolk and cutting off access on high flood days to the base is it's a national security issue. So it's not just an inconvenience. Some people call it nuisance flooding. Well, that's not a very apt name because it's more than a nuisance, right? It can keep people from getting to the doctor or the hospital. It can keep people from getting to work, or in this case, to the base. So that changes the outlook too. When it becomes a national security issue, then it tends to get a lot more attention as well. The Union of Concerned Scientists actually did an interesting study looking at anticipated impacts of sea level rise on military bases around the country. And of course, Norfolk and Langley Air Force Base, by the way, both were two of the most heavily impacted. Did you want to add something to that, Molly?
Yeah, I mean, I think it's the flood experience that really gets people thinking about it. In Virginia, the urgent need to deal with sea level rise started in Norfolk. And it was because the residents were getting flooded and they were starting to see economic impacts from that flooding. And it kind of grew out of there. And now most of the Virginia localities are at least somewhat aware of the issues and addressing them in some extent. But I think, it's still a hard pitch maybe to the interior part of Virginia, which is not seeing the impacts of sea level rise. Why do we care if people in Norfolk are getting flooded out? So I think the thing that makes people care, but which hasn't been terribly transparent, is the economic value of, say, the Port of Virginia to the whole rest of Virginia. If we can't get goods to the port, that doesn't just affect, that area. It affects all of the state because that is, where our economic value is coming through. So Northern Virginia, Hampton Roads, Richmond, all waterfront. And so these are our big economic centers. And I think we're not yet, it hasn't gotten to the point yet where we're starting to see those economic issues resonate throughout the state, but that's going to happen at some point. So
Yeah.
I think really good transparent information on that, I think could help people who are not experiencing flooding care about the issues.
And another thing that, and I saw someone pointed it out in the questions, our State Department of Environmental Quality has gone to the 14 top groundwater withdrawal permittees and negotiated reductions in the permits. And that helps as well. Molly showed that, I guess, was it an existometer map? I don't remember what you showed, but you showed the concentrations of, we have the West Point paper mill, and there's another one in Franklin. And that's where a lot of that groundwater withdrawal occurs. In Franklin, the paper mill was shut down for a while, and the actual level went up of the aquifer went up again, which goes to show that severe withdrawal does impact it. So anyways, yeah, so I think that cutting back on those permits, that was a serious step that the state took to try to curtail the overuse of the aquifer.
Excellent. Well, thank you both so much. And on behalf of the entire crowd here today, we were thrilled to get to hear this discussion. As we close, could you each give us one thing that you're hopeful about? I know the discussion's been a little bit maybe overwhelming for some of us because of the impacts this is going to have. So give us something to close with that leaves you a little bit hopeful at the end of the day.
So I always like to remind people that compared to a hurricane coming, sea level rise and climate change is a relatively slow crisis, okay? We have impacts happening today, but the big impacts may be 10, 20 years off. If we know they're coming and we plan and we take action, they don't have to be a crisis. They can be something that's just part of the fabric of our society.
And I think I would echo that just as a final note. You can make a difference. You can make a difference by educating yourself and educating your family and educating your neighbors and educating your community about what this is. And it's encouraging that we are, as you said, Rob, we're talking about this now, right? And that's a change in some ways. So let everyone know and create political will for addressing it through education.
Well, thanks again so much. And thanks for everyone who attended and provided all those really thoughtful questions. I'm sorry we didn't get to them all today. Maybe we could plan for another event like this in the future, because it seems like there's a lot of interest in this discussion. Tim, did you want to add anything at this point? I think we're all set then. Well, thanks again, and we'll see you all again soon.
Thank you.